A 2,000 seat theater has tickets for sale at $15 and $22. How many tickets should be sold at each price for a sell performance to generate a total revenue of $33,500? So let's read them again. Highly recommend you read word problems at least 2 to 3 times in order for it to actually make a little sense sometimes. So a 2,000 seat theater has tickets for sale at $15 and $22. How many tickets should be sold at each price for a sell performance to generate a total revenue of $33,500? So let's go back to it again. We know that it's a 2,000 seat theater, so 2,000 people can sit on there, right? And it has tickets for sale at $15 and $22. Well, if you're up towards the front, your ticket price is $22. Way back there at the back where you can barely see, where you need binoculars to actually be able to see people in the front, they charge you $15. Plus you get to bring in your binoculars for free. Okay, so let's also realize that they need a total revenue of $33,500. Okay, so total of seats, 2,000, and total revenue, $33,500. We got the totals. But it also tells us the tickets are priced at $15. And let's notice the word, where is that word? So, seats has it, and how many tickets should be sold at each price for the performance? Well, I guess it's not implied in this case. So, let's take a look and assume that in this case they don't tell us what variables to use, so we're going to randomly select variables. Let's assume that seats at $15 are tickets A, so we also have $22, which we're going to call seats at B. So if you sum up the total of seats or people, depending on the case, right? What do? Well, you typically just count, right? You get the total from one area plus the total from the other area, and how do you get the total? Give it away. We're adding, right? You add to get the total. So let's start out with the total number of seats. In order to get the total, 2,000 seats, we take A and B, and what do? Add, subtract, multiply, or divide. Which would you prefer? Once again, we probably want to add the number of seats or number of tickets sold at A price plus the number of tickets sold at B price. Well, number of seats, right? Because we're not talking about price yet. This is just number of seats. So it's added. We're going to add A plus B. Gives us a total of 2,000 seats. Now let's talk about a price or revenue. So total revenue, $33,500. We know we're going to sell tickets A at price $15 and B at $22. When we add the total, we should get a total of $33,500. In order to get the total for how much we earn from tickets at price $15, that's A, right? We got to multiply. So we're going to multiply 15 times A to get the total for seats sold times the cost will give us the total cost at A price. And also likewise at B price, which is $22. 22 times B, in other words. So there, we got two sets of equations which we can solve either through substitution or elimination. Agreed? Let's try using substitution in this case. So meaning we're going to solve for one of the equations. Let's solve for the top one. Seems to be fairly easy, fairly straightforward, right? If we solve for, I don't know, maybe something like A. So let's get rid of the B then. In that case, if we're solving for A, we got rid of the B then. Minus B from both sides. And that gives us 2,000 minus B equals A. And once again, we're solving using substitution. Agreed? So now that we have a formula and we have a variable solved for in terms of the other variable, we're going to replace it back into one of the original equations, meaning the second equation that we haven't used yet, the revenue one. So we have $33,500 equals 15 times, and we replace the A value for the formula we just found, which is the A value as well. 2,000 minus V equals A. So there it is, plus 22B. And now let's distribute the 15. So we have 33,500 equals 15 times 2,000 gives us 30,000. 15 times negative b gives us negative 15b. And now we can simplify. Let's combine the b's. Negative 15b plus 22b gives us 7b. Agreed? There it is. And now to solve for b, let's get rid of the 30,000. So minus 30,000. Cancel out the 30,000. And 33,500 minus 30,000 gives us 3,500. There we go. Which equals 7b. That's what was left on the right side. Agreed. Now let's solve for b. The 7 is multiplying with the b. Opposite of multiplication? Division, right? So dividing by 7 on both sides. There we go. 7 divided by 7 cancels out. 3,500 divided by 7 now gives us 500 equals b. So b is the number of tickets sold at price for $22, right? There we go. So we got the 500 tickets were sold for $22. Yeah, after all, there's only a few seats that are up at the front, right? They're not as many as we can probably visually see. So 500 tickets roughly is what costs $22. So how many tickets were sold at $15? Way further to the back where you can barely see. So let's substitute the v value back into the previous equation. 2000 minus v equals a. So substituting 2000 minus 500 equals a. So that gives us that 1,500 tickets were sold at price A, which is $15. So once again, 1,500 tickets sold at $15. And here in this case, we now have both values. Tickets sold at A price, which is $15, 1,500. Tickets sold at $22, 500.